Hello everyone, welcome to another lecture of the course Digital Signal Processing. In the previous lecture, we have considered an example for DIT-FFT, that is Decimation in Time Fast Fourier Transform, and we had considered the value of n as 4. So now let us consider an example in which we need to find the 8-point DFT of a discrete time signal x of n, which is given like this. So it has the sequence 1, 2, 3, 4, 5, 6 and 7, where this 1 is located at n equal to 0. So we need to find its 8-point DFT using this DIT-FFT algorithm, and we know that the first step is to perform the bit reversal. So the step 1 is performing bit reversal. And the initial sequence is given like this. So this is the initial given sequence of our signal, and we know that the n here is 0 and the highest value that we have here is 7. So this 7 can be represented using 3 bits. So this 7 here can be represented using 3 bits. So we are going to consider the 3-bit representation for its binary, so that can be given as 0, 0, 0. This 1 can be represented as 0, 0, 1. This 2 can be represented as 0, 1, 0. This 3 can be represented as 0, 1, 1. This 4 can be represented as 1, 0, 0. This 5 can be represented as 1, 0, 1. This 6 can be represented as 1, 1, 0, and this 7 can be represented as 1, 1, 1. Now the number of bits, as we had seen in the previous lecture, that is m, can be obtained by using this formula log to the base 2l with a seal, where this L is the length of the signal that we are having. Here the length of the signal is 8. So what we can do is this m can be given as log 8 to the base 2, which is equal to log 2 to the power 3 to the base 2, which comes out to be 3. So we are considering the 3-bit representation. Moreover, we had seen that the number of bits required for the bit representation, that is m equal to 3, is exactly the number of stages that we require in the butterfly structure in order to find the DIT-FFT. So we need total 3 stages of this DIT-FFT butterfly structures. But before that, we need to perform this bit reversal, and we have this binary representation of this n that we have here. So now let us do its bit reversal, and the bit reversal can be obtained by just flipping the bits. So flipping the bits, or what we have here is 0, 0, 0. The bit reversed format of this 1, that is 0, 0, 1, will be given as 1, 0, 0. This 1, 0, 0, 1, 0 would be as it is. This 0, 1, 1 would be now 1, 1, 0. This 1, 0, 0 after bit reversal would be 0, 0, 1. Then this 1, 0, 1 would remain as it is. This 1, 1, 0 would become 0, 1, 1, and this 1, 1, 1 will now become 1, 1, 1. And now if we find its decimal representation, so what we have here is 0. This 1, 0, 0, if we observe here, so it is 4. So we have here 4. Then this 0, 1, 0 is 2 as it is. This 1, 1, 0 is basically 6. So we have 6 here. This 0, 1, 1 is 1. This 1, 0, 0 is 5, which is as it is here. This 0, 1, 1 is basically 3. So we have 3 here. And this 1, 1, 1 is 7 as it is. So therefore the final sequence that we need to use in order to compute the DFT is given as x of 0. Then we need to consider x of 4, then we need to consider x of 2, then we need to consider x of 6, then we need to consider x of 1, then we need to consider x of 5, then we need to consider x of 3, and finally we need to consider x of 7. So this is the sequence that we need to consider in order to find the 8-point DFT of the given signal. So this is the sequence that we need to follow. So we have x of 0 as 1, x of 4 as 5, x of 2 as 3, x of 6 as 7, x of 1 as 2, x of 5 as 6, x of 3 as 4, and x of 7 as 8. And we know that we require total 3 stages. We require m equal to 3 stages. So let us consider the first stage. And we know that in the first stage we need to consider the 2-point DFTs by combining consecutive 2-2 groups like this. So the first group would be these two, so it would be like this. And we know that the scaling factors would be 1 here, 1 here, 1 here, but a -1 here, and the twiddle factor would be W2 to the power 0. As we have a 2-point DFT here, so it would be W2 to the power 0. Similarly, we are going to get similar structure for remaining 3 parts. So we have like this. So scaling factor 1, 1, 1 and -1. Similarly here. And the twiddle factors would be again W2 to the power 0, W2 to the power 0 and W2 to the power 0. So the point or the value that we are going to obtain here would be 1 plus 5 into W2 to the power 0. So this W2 to the power 0 has a value 1. So we are going to get 1 plus 5. So that would be equal to 6. So the value that we are obtaining here is 6. Similarly, the value that we are going to obtain here would be 1 minus 5 into W2 to the power 0. So it would be 1 minus 5. So that would be equal to -4. So the value that we are having here would be equal to -4. Similarly, the value that we need to get here would be equal to 3 plus 7 into W2 to the power 0. So it is 3 plus 7. So that would be equal to 10. So we are having a 10 here. Similarly, here we have 3 minus 7 into W2 to the power 0. So it is 3 minus 7. That would be equal to again -4. So we have -4 here. Now the value that we need to find here would be 2 plus 6 into W2 to the power 0. So it is 2 plus 6, that is equal to 8. So we have 8 here. And the value that we need to obtain here would be given as 2 minus 6 into W2 to the power 0. So it is 2 minus 6, that is equal to -4. So again we are having -4 here. Similarly, at this point we require 4 plus 8 into W2 to the power 0. So it is 4 plus 8, that would be equal to 12. And at this point we have 4 minus 8 into W2 to the power 0. So it is 4 minus 8. So that is equal to -4. So we obtain -4 here. And we know that this is the first stage. So this is the stage 1. and after stage 1 the output that we obtain is 6, minus 4, 10, minus 4, 8, minus 4, 12 and minus 4. And now using this output we are going to consider the 4-point DFTs, and for that we are going to consider two groups. So it would be, first group would be this first 4 values and second group would be this second 4 values, and then we are going to compute the 4-point DFTs for each of those two groups, and that would be our stage 2. So let me just extend these lines further like this. And let us consider the first group that we have. So that would be this one, whose 4-point DFT we need to calculate, and for that we are going to combine this 6 and 10 and this minus 4 and minus 4 here. So in order to combine it, we are going to have the butterfly structure like this, and the scaling factors would be 1, 1, 1 and minus 1 here, and the twiddle factor would now be W4 to the power 0. And the second group that we have, or the second part here that we have, would be like this. Again, the scaling factors would be 1, 1. So here would be 1 and here it would be minus 1, and the twiddle factor now would be W4 to the power 1. So now we need to find these 4 values for the first group. So if we need to compute this value here, so it would be 6 plus 10 into W4 to the power 0. So that would be 6 plus 4, that would be equal to 60. So it would be 6 plus 10, so that would be equal to 16. So we have the value as 16 here. And another point of the same butterfly structure would be this 6 minus 10 into W4 to the power 0. So it would be 6 minus 10, that comes out to be minus 4. So the value that we obtain here is minus 4. Similarly, the point here can be obtained as minus 4 plus minus 4 into W4 to the power 0. So this W4 to the power 0 can be written as, so it is W4 to the power 1 can be written as e to the power minus j 2 pi by 4 into 1. So this comes out to be e to the power minus j pi by 2, and this is equal to minus j. So this W4 to the power 1 is basically equal to minus j here, and therefore what we obtain is, at this point it is minus 4 plus minus 4 into minus j, so it comes out to be minus 4 plus j4. So the point that we have here is minus 4 plus j times 4. Similarly, the point that we obtain here is minus 4 minus 4 into minus j, so that comes out to be minus 4 minus j4. So the point that we have here is minus 4 minus j4. Similarly, we need to compute the values for the second group. So that can be obtained by having a similar structure here also. So we have it like this. So this is the first butterfly structure that we have, and this would be the second butterfly structure that we need to consider. The scaling factors would be 1, 1, 1. So here also 1 and 1. Here it would be 1, it would be minus 1 here, and it would be minus 1 here. And again the twiddle factors would be W4 to the power 0 and W4 to the power 1. And in the similar way we need to find the values at these 4 points. So at this point we have 8 plus 12 into w4 to the power 0, so it is basically 8 plus 12, so that comes out to be 20. So we have 20 here. Similarly, at this point it would be 8 minus 12 into 4 into w4 to the power 0, so it is 8 minus 12, so that comes out to be minus 4. So again we have a minus 4 here. If we observe this point, so it is minus 4 into w4 to the power 1, and we had found that this w4 to the power 1 comes out to be minus j, so it is minus 4 plus minus 4 into minus j, so this at this point we have minus 4 plus j4, and similarly at this point we have minus 4 minus 4 into minus j, so here we have minus 4 minus j4. So here we have minus 4 minus j4. So this is the second stage, that is stage 2. Now at the output of the stage 2, what we have is 16 minus 4 plus j4 minus 4 minus 4 minus j4, then 20, and minus 4 plus j4 minus 4 minus 4 minus j4. And we had seen that we require in total 3 stages. So therefore we need to consider a last stage, and the last stage would be 8-point DFT. That is, we need to consider both of these groups and combine them. That is, combine both of these groups in order to get the final DFT. So let me extend these lines again further. So something like this. And now we need to combine the point here with the point that is available here. This output here is to be combined with the output here. The output here is to be combined with the output here, and the output here is to be combined with the last value. That is, the corresponding outputs are to be combined in the similar way which we had done here also. Like this 6 has to be combined with 10, this minus 4 with this 4. Similarly, this 16 is to be combined with the first output of the second group, and so on. So what we are going to have is something like this. So this 16 is to be combined with 20 like this, and we have the scaling factors as 1, 1, 1 and minus 1, whereas the twiddle factor is given as w8 to the power 0, and the point that we obtain here would be given as 16 plus 20 into w8 to the power 0, so that comes out to be 16 plus 20, that is equal to 36, and this gives us the value of x of 0, which comes out to be 36. Similarly, the value that we are going to obtain here would be given by 16 minus w8 to the power 0 into 20, so that would be 16 minus 20, that comes out to be minus 4, and this is the value of x of 4. So what we obtain here is x of 4, that comes out to be minus 4. In the similar way, we need to combine this minus 4 plus j4 with this minus 4 plus j4 of the second group. So it's something like this. Again, the scaling factors are 1, 1, 1 and minus 1, and now the twiddle factor is w8 to the power 1, and now this point here can be calculated as minus 4 plus j4 plus minus 4 plus j4 whole multiplied by w8 to the power 1, and when we solve it, the value that we obtain here comes out to be x of 1 is equal to minus 4 plus j times 9.6569. And the value that we are going to get here would be minus 4 plus j4 minus w8 to the power 1 into minus 4 plus j4. So this comes out to be x of 5 is equal to minus 4 minus, so let me write it like this, minus j times 1.6569. Similarly, we need to combine this minus 4 with the minus 4 here. So like this. And the scaling factors would be again 1 here, 1, 1 and minus 1. And now the twiddle factor would be w8 to the power 2. And the point here is obtained as minus 4 into w8 to the power 2, so that comes out to be x of 2 is equal to minus 4 plus j4. Similarly, the value here, that is x of 6, is obtained as minus 4 into minus 4 into w8 square, so that comes out to be x of 6 is equal to minus 4 minus j4. And the last group that we need to consider is something like this. So we have it like this here, and in the similar fashion we would be getting the similar scaling factors here like this, and we would be having a minus 1 here, and the twiddle factor would be w8 to the power 3, and this point here can be calculated as minus 4 minus j4 plus w8 to the power 3 into minus 4 minus j4. So this x of 3 comes out to be minus 4 plus j times 1.6569. Similarly, this point here can be obtained as minus 4 minus j4 minus w8 to the power 3 into minus 4 minus j4. So the value that we get here is x of 7, which comes out to be minus 4 minus j times 9.6569. So therefore, what we obtain is x of k is equal to 36, which is located at k equal to 0. Then the second point, that is x of 1, is obtained as minus 4 plus j times 9.6569. Then we have minus 4 plus j4. Then we have minus 4 plus j times 1.6569. Then we have minus 4. Then we have minus 4 minus j times 1.6569. Then we have minus 4 minus j4, and at last we have minus 4 minus j times 9.6569. And this is what we obtain the 8-point DFT of given x of n using DIT-FFT. And we know that this last one is the stage 3. Now after this example, let us try to generalize certain things. That is, we have considered it for a particular value of m and n. So we know that we can find the value of m using this formula. So from this formula, let us try to generalize the things. So generalizing for any length signal so for that what we will consider is, let L be the length of the signal. Now in order to find the DFT at the very initial stage, we need to do the bit reversal. That is, for that we need to know the number of bits that should be used in order to represent all the values of n that we have in this x of n sequence, as well as we need to know what is the number of stages in this butterfly structure, so that we can properly find out the DFT. And we had seen that this number of bits is exactly equal to the number of stages that we obtain. So what we can say is, in general, number of stages can be given as log of L to the base 2 but with a seal. So let it be represented by m, and once we have this m and we know that this L need not be equal to n, so in that case the value of n, the value of this n can be obtained by as 2 to the power m. Now once we have these stages here, then we need to decide the value of twiddle factor for each stage. That is, we need to know what would be the twiddle factors at each stage. So we need to have the value of this subscript, as well as we need to know how much the value of this superscript is going to change. So basically for ith stage, what is the twiddle factor? And this I would be varying as 1, 2, 3 and so on till m. As we are having m stages, so this I would be varying like this. So the twiddle factor at ith stage can be given as w 2 to the power I to the power k. So if we observe it carefully here, at the first stage this w 2 to the power 0 is considered. So we have a w2 here and I value is 1. So we have w2 to the power 1, so that is w2. Similarly at stage 2 we have w2 to the power 2, so we have w4. At the stage 3 we have w2 to the power 3, so that is w3. Now the next thing that we need to check is what is the range of this k, and this k should be varied from 0 to 2 to the power I minus 1. Sorry, 2 to the power I by 2 minus 1. So if we observe here I is equal to 1 and 2 to the power I is 2. So if we consider 2 to the power I by 2 minus 1, so that will be equal to 2 by 2 minus 1, that is 0. So the value of this k is from 0 to 0, that is only 0. Thus at second stage we have 2 to the power 2, that is 4. So 2 to the power 2 by 2, that is 4 by 2, that comes out to be equal to 2. So that would be 2 minus 1, that is 1. Therefore the value of k comes out to be 0 to 1. So let us try to understand it better. If we consider I equal to 2, so let us consider I equal to 2, that is the second stage. So in that case, the twiddle factor would be given as W2 to the power 2 to the power k. So it would be equal to W4k, and this k would be varying from 0 to 2 to the power I by 2 minus 1. So we have 2 to the power 2 by 2 minus 1. So that is equal to 4 by 2 minus 1, which is equal to 1. So therefore, what we have here is this k would be varying from 0 to 1. So if we observe in our structure here, at the second stage we have W4 to the power 0 and W4 to the power 1. So same thing that we are obtaining here for the second stage. This twiddle factor is W4 to the power k, and this k takes the value as 0 and 1. So in this lecture we have considered an example for n equal to 8 point DFT and solved it completely using the DIT-FFT structure, and we then further generalized the number of stages, then the value of n and the twiddle factors for the ith stage for any given length of signal, and we found that the number of stages is given by log L to the base 2 but with a seal which we denote by m. The value of n is to be chosen as 2 to the power m. We said that for ith stage the twiddle factor is given as W 2 to the power I to the power k, and this k varies from 0 to 2 to the power I by 2 minus 1. So let's stop here. Thank you.